This is an endgame setup for running local AI agents today. With 1 terabyte of memory, a high-speed RDMA network, 160 fast ARM cores, and lots more, it can run giant models, even huge ones like Kimi K2.5 or Qwen 3.5 397B. Back in the day, managing clusters of nodes, RDMA networking, network storage for AI containers, and more would be something that would be challenging. But now you can just tell OpenCloud or Cloud Code to go do it for you, and so there's essentially no barrier to entry other than the price of the hardware. With that, we have a lot to get to today, so let's get to it. Hey guys, this is Patrick from STH, and this is an 8-node NVIDIA GB10 cluster. To make this cluster, we took 8 different GB10 nodes because we got them based on what we could afford to do. Plus, we got 2 of these switches I saw back in Latvia last summer and some 10 gig networking to create an awesome little cluster. Look guys, I know that we have a scary history of like a decade plus of setting up AI clusters that have Ansible playbook. You might see terms like Rocky V2 or RDMA networking, tensor parallel, or something like that, and you might get really nervous because you may not know what those are. You might even think that setting up a cluster like this would be super time consuming. Key takeaway of this is definitely going to be that having 8 of these NVIDIA GB10 nodes scaling out in a cluster is awesome. But to me, the more impactful thing was that the barrier to entry to this is effectively 0 now. We can just tell Cloud Code or OpenCloud with a decently large model in the back to go set this all up. We just literally get this to the point that we have login prompts, give it to these tools, and they do everything for you these days. And when I say it does everything, I don't just mean like, oh, it's gonna set up the infrastructure. It'll do that, but it also will go and get the VLM working and serving your models to OpenClaw or other tools. It'll start optimizing and try and figure out, oh, hey, could we get a performance optimization if we launched the model with some different flags or what have you? It'll also do fun things like do documentation for you, so you don't have to do that. It can monitor it for you, so you don't have to monitor it. It will literally run your entire cluster like if you had an IT admin, which is kind of scary, actually. I will definitely say this. There was a point right before I said Cloud Code and OpenClaw on this, I was thinking, I was like, I'm giving like networking and I'm giving like a lot of compute. Like, let's face it, this is a lot of compute and a lot of resources. And I'm just giving login details to an AI agent and saying like, go for it. And I was like, I think this might be how Skynet started, and definitely is not great from security, but it worked. So, kind of cool. Now, while we had a lot of this, it did require a trip to the sponsor of this video, Micro Center, to go get some odds and ends. We'll go there in a little bit, but I just want to say thank you to Micro Center for sponsoring this video. As you might imagine, this was not a cheap video for us to do, so having a sponsor for this one really helps. But because this is STH, let's get to the hardware. So let's get into the chaos of what having 8 NVIDIA GB10 systems really looks like. Because you're gonna probably see a lot of thumbnails that look really pretty, but this is the spaghetti behind the scenes. So let me just show you what we have here. We have 2 of the Lenovo PGX systems that you're gonna see up front. Then you're gonna see that we have a NVIDIA DGX Spark system. Then we have 2 Dell Pro Max with GB10s. Then we have 3 of the Asus Ascent GX10s, or the Asus GX10s. The reason that we have 3, by the way, of those Asus ones is Asus sent one, and then we bought 2 of them because they were the lowest cost ones when we purchased them, and they've gone up in price since we have. Now, a lot of folks will show you that front, but to really get a real cluster going, there's a lot more that you need. So going behind these, you're gonna see this total rat's nest of cables. And let me decipher it a little bit for you. We have different power adapters for all of these units. And so when you have 8 GB10s, you also have 8 power adapters that all have to go to USB-C, and I think they all have to deliver 240 watts to the GB10. That means that we need at least 8 PDU ports, so you probably don't just have a simple power strip, you probably have a PDU. Here we have the Ubiquiti Power Distribution Pro, which has extra ports, because the next thing that you're gonna need, especially if you wanna have a real cluster, is you're gonna need 200 gig networking. And each of the ports on the back of these GB10s, they can do actually about, with if they have a PCIe Gen 5 by 4, you can actually get about 109 gigabits per second out of them. Now we have an article on this, so if you wanna learn more, it's definitely super important. But what you're gonna see is that on the back of this, you have these 2 QSFP ports. And specifically what you're gonna do is you're gonna use one of them, and you wanna run a QSFP 56 cable to one of them, and you want it to run at 200 gigabits per second. So that way you can have both the PCIe Gen 5 by 4 routes, can go into the Connect X7 NIC, and out a 200 gig port over here. Now it shows up as 2 different interfaces. Actually, this shows up as 4 different interfaces, but you're gonna only use 2 of them. One other just kind of little tip, especially if you're gonna start getting a lot of these, is that you wanna use either port 0 or port 1. You don't want to use random willy-nilly ports on all 8 of them, because otherwise your life is going to be it's just going to be horrible to go and set these up on the software side, right? Other things that are important that you're going to see that we already have set up over here, we have a MikroTik CRS 804DDQ switch. Now, funny story, when we did the MikroTik Latvia tour earlier in, I guess, the summer of 2025, I saw the prototype for this, and it was explained to me that the idea with this was a campus switch that, like, you know, between campuses, you put an optic in here and go 400 gigabits per second, which is super cool. But on the other hand, I looked at it and I said, hey, actually, no, make sure that Rocky is working on here, and this is going to become the big switch for the NVIDIA GB10 ecosystem, because this is a great way to go and scale to 8 units. Because what you can do is you can go and with these ports, these are QSFP DD or double density or QSFP 56 DD ports, which means that you get essentially 2 QSFP 56 200 gig ports on each of them. And if you want to go learn about QSFP versus QSFP DD, we have a whole guide on the STH main site and can show you all the connectors and stuff. But the idea here is that we're going to break each of these 400 gig ports out to 2 200 gig ports, and then those 200 gig ports will end up going into this over here, which is you can run this port on the GB10 as 200 gigs as well. So that's how you're going to get your 200 gig networking. If you're wondering if you could use optics to do something like this, yes, you can. But of course, you want to use copper because it's lower power and more reliable. So always use copper where you can, optics where you need to. Now, another thing that you could do is, of course, you could get 2 of these switches and you could split out the ports and only run them at 100 gig and then use both ports on the back of the GB10. What that would allow you to do is actually get more units onto a pair of these switches all in a cluster, because you could have 2 essentially 100 gig or 109 gig rails essentially to your network, right? So that's a higher end thing. So if you have like higher end GPU clusters and HPC clusters, you might see a topology like that. You don't necessarily need that here, but the advantage is that you would get 2 400 gig ports with 8 of these connected. You'd have 2 400 gig ports on each switch to go up to a bigger network or for something like storage. Now, if this looks like a complete rat's nest, I 100% agree with you, but this is kind of the minimum configuration, because you don't really want to run your management traffic on your ConnectX 7 and Rocky ports. Instead, what you really want to do is have a separate network for that, so that way you're not putting more packets on a network that you want to be going as fast as possible. So now, of course, Rocky, the idea with that, of course, is that you have the priority and you won't, that the management traffic won't really get in the way. But on the other hand, it's just way easier to just go separate it out. Now, these all have Wi-Fi built in. So this is a minimum configuration. We can use Wi-Fi. We can go do our SSH access and what have you all through that Wi-Fi connection, and that makes life good. But you know what we really need to do? We need to go and get some 10 gig cables. The sponsor of today's video, Micro Center, because it's so convenient to have a Micro Center nearby. They just opened this location in Phoenix, Arizona, so we can go pick up all the things that we need. We buy things here like network cables, because we're gonna need a lot of those for this cluster, and also fiber optic cables, because we're gonna do our uplinks with fiber. And if we needed one, we could get another NVIDIA DGX Spark here, because they have GB10 systems in stock, and actually this one's less costly than if you were to go get it on NVIDIA's website right now. And for the 10 gigabit networking in our cluster, we can just go get a 10 gigabit switch here, exactly like this one. We actually bought our review unit here at Micro Center because it was easy to just go drop by and pick one up, and that's what we're gonna be using to prototype our cluster with. And I know some of you are gonna say, hey, you can go way faster if you're using a GPU for AI and maybe run a smaller model but much faster, and you totally can. They have those, of course, at Micro Center as well if you want to pick one up. And by the way, there's not just computer and networking components here. They have tons of things, everything from regular printers to 3D printers. So we're gonna go check out now with our new collection of network cables and get back to our cluster so we can get that up and running. Okay, now that we're back from Micro Center, super handy to have one of those down the road. We have our Ubiquiti 8-port 10 gig switch. Now this is a PoE switch, you definitely don't need that. Also, one nice thing is that we have our 8 ports of 10 gig for all of our GB10s, but we also have 2 SFP Plus ports. So if we wanted to, we could do like a SFP Plus to 10G base T adapter and go to the switch, and we can use another one to go to the rest of our network. And that would give us just a lot of management options here. Now we have a complete rat's nest of cables, but we have 8 NVIDIA GB10s fully connected, and I want to show you a little bit about how much power these things use real quick. So this whole cluster is using about 400 watts right now, and by the way, if we were running a real AI inference workload on here, you would see this go up by another maybe 800 to just under 1,000 watts.
So, this can definitely use a lot of power as a cluster. But one thing I'll definitely say is that it is relatively quiet. By far the loudest thing here is the MikroTik CRS 804 switch, but that is actually not super loud. And also I just want to point out that one of the reasons that we're using the Ubiquiti Power Distribution Pro here is because even though it doesn't have like the highest resolution on reporting its power, something that is really useful is just being able to go look at the per port power consumption when you have 8 nodes. The reason for that is that if you have the ability to look at the power consumption, if you see one of these GB10 nodes running at like 35 to maybe 45 watts, that usually means that it's sitting idle. On the other hand, when they're loaded and they're actually in use, maybe at the low end, probably about 80, 90 watts, but realistically a lot of times between maybe 110 and 140, 150 watts is pretty just normally what you would expect to see. So if you have that ability to monitor the power based on each unit, then that gives you the ability, of course, to go and see if one of them's not behaving properly. Also, if you ever had to bounce one, having the ability to go and turn off these outlets on a per port basis is always useful. You're probably looking at this and saying, oh my gosh, Patrick, you have plugged in a USB-C power, you've plugged in a 10G-based port, you've plugged in a QSFP56 port to each one of these nodes. That's 3 connections, 8 different nodes. I mean, we are talking about 24 different connections. That doesn't even include some of the extra switch stuff. Now, you might think that this is so complex, and just setting this up, having to set up the switches with Rocky, having to set up get all the updates running, just get everything working and sorted out is a total pain, especially if you've been using 1 or 2 of the units or maybe 4 of the units and you're expanding the cluster. And let's get over to the other set, and we're gonna talk a little bit about why this thing was so much easier to set up because we were using OpenClaw.
Okay, now the first step in all this, of course, is you have to unbox all this, which is, there's a lot of hardware here, guys. So that actually takes a little bit of time. The other thing I would do is I would start to set up these systems. So you can get these set up, get the initial username, password, initial configuration, do that initial setup updates before you put them into the cluster. And by the way, while we just fed the credentials for these into Cloud Code and OpenClaw, something that happened was one of these we didn't have like a base configuration because we'd use it for a number of different pieces. And so we were getting like weird performance because of it. And that was a troubleshooting step that the AI tools managed to do no problem. But also if you have fresh configurations, that would make life a little bit better. But I say this because it's important because I think a lot of folks are going to start with like 1, 2, 4 of these and then maybe go up to 8. And so if you have nodes that you had been using with brand new nodes, they may not have the same base configurations. And that's something that you want the AI agents to go work on because otherwise, your networking is going to be a total not great place to be. Next, you have to do the MikroTik CRS 804 DDQ things and tips here. You need to make sure that the auto negotiation is off. You want to set these to 200 gig ports. That way you have access to 200 gigs. For some reason, didn't auto negotiate for us. Don't really know why, but just set it manually. Also, you're going to want to change the MTU because that's something that usually we do for a Rocky, setup. And then the other very big one is that you also want to make sure that you have the right QoS settings for, running Rocky V2 or, having RDMA networking on here. So like PFC, ECN, all that kind of stuff. Now, of course, we just let the AI agents do it because that was way easier. But on the other hand, it's something that I would definitely tell an agent to do. So that way they don't use like the 10 gig networking and say like, oh, this is great. You really want to make sure that they're running that 200 gig networking, testing it and making it all, work with RDMA, right? Another point is you might have to set up your 10G based T switches. Whether you have, a Ubiquiti switch and you have a Unify setup, you have a Cisco setup, whatever it is, you do have to set those up, or you may have to. But on the other hand, you don't really need to do such fancy configurations to get something that's very usable because at the end of the day, even if you don't set jumbo frames or something like that on there, the performance is going to be pretty good. It's mostly going to be used as a management network. So you just don't have anything that's really that exciting, but you may have to do things like VLANs or whatever to put it on your network. Now, another important thing I would tell you to do, or an AI agent, is to make sure that you're testing, especially the networking, before you get started and start setting up like VLM and try running workloads. Now, another thing that we needed to do was set up our network storage because that was one of the ways that we're lowering the cost per node is to have, more cost and more in our NAS for storage. And so that's something that we had to do. And we had the AI agents do that. We just gave the login details and said, go. And a quick tip there, by the way, is to make sure that you're using a different username and password, of course, for your AI cluster than you are for your storage management. And also set up folders for things like where you want to have like a working directory and also have one for AI models so you can download download and use them elsewhere. The other key thing is just make sure that you do things like have snapshots. So that way, if something really bad happens and you end up like deleting everything from your working directory, at least because you have that separation of your permissions from like these boxes versus your admin console, at least that gives you a ability to have snapshots and get a couple second resolution to a problem rather than just losing everything, right? So it's a big deal. Make sure you set up your storage right. Another super important aspect of this is make sure that if you're using an AI agent especially, or even if you're not, make sure that you're documenting the setup, because if you have to go and change something later, we actually had to swap out one of the nodes because it had to leave the studio, and so we had to swap in another node, and having that documentation meant that swapping it in and out was like it took like 5 minutes for the agent to go do that, and it was like super easy. So just from my perspective, I would always make sure that you have that good documentation to rely on, so that way you can point either a person or an AI agent to it later. Now, of course, we'll have some artifacts on the basic setup that you can feed into an agent on the STH main site. But to me, guys, that was one of the biggest things, was just being able to set this up without me having to go in and actually do it. Okay, now what everybody wants to know is about performance, because that's of course important, but at the same time, having only 273 gigabytes per second of LPDDR5X memory bandwidth doesn't necessarily give you the best setup for maximum performance in a modern, LLM mode, right? So something that's really important is that instead of thinking of this as a maximum tokens per second game, think about it as a maximum flexibility in what you can run, especially at that cost and power envelope. And guys, why I wanted to do this in the first place was I wanted to run Kimi K2.5, which is absolutely giant. Just to give you some idea, even at FP16, Kimi K2.5 and now K2.6 take like over 2 terabytes of memory. If you go down to like 8-bit, you're talking about over 1 terabyte of memory. And even if you're down at the 4-bit quants, you're still talking about like often like maybe 610 to 650 gigabytes of memory, which means that if you want to maintain that level of fidelity and you don't want to go down to like a 2-bit quant or something like that, you need something like, 7 or 8 NVIDIA RTX Pro 6000 Blackwell Edition GPUs. Now, of course, that will be much, much faster than this, but it'll also use a lot more power, like over 3 times as much power. And it'll also cost more. So instead of thinking about performance solely in the tokens per second, which of course is super important, I'm not saying it's not, but think about the performance in terms of being able to test at higher fidelity, higher quantization levels, right? Or just being able to run the larger models and getting better quality because you're running those types of models rather than going down to like that 2-bit quant to be able to fit it into a GPU, footprint that you have enough memory for, right? And that's really the idea of the GB10. We're not talking about performance solely in tokens per second, we're also talking about quality. And just in case you're wondering, Kimi K2.5 and we're running K2.6 right now, and it's about the same. You're talking about 3 to 4 tokens per second is usually pretty good at a concurrency like 1. If you go up to like 32 concurrency, you might get into like the 30 to 42 tokens per second range. But you're definitely, you're not going to be running like 600 tokens per second by any means. But then again, you're also able to run that quant, and you're able to run it at like 950 watts for the entire cluster, including switches. And by the way, even doing that, you still have about 110 to 120 of the ARM cores free, and you usually have 200 to 300 gigabytes of memory free. So if you have to run something like OpenClaw or Turnstone Hermes, or any of those types of things, you can go do that because you just have extra cores and memory. And guys, realistically, here's the challenge that we kept running into. I wanted to do this with Kimi K2.5, but then now Kimi K2.6 is out, so I have to re-record this section while the thing's actually running right now. Also, we did Minimax M2.5, but then 2.7 came out. GLM 4.7 became GLM 5.1. By the time we go and run through a bunch of benchmarks, try different optimization steps and what have you, then I have to go record the section, it has to get edited and all that kind of stuff. Like it's just a nightmare to actually do these. But since we've been using this cluster for like 2 months and it's been running nonstop for like 2 months, I do think that there are some key like high level concepts that are important just to understand the overall performance, or at least frame the overall performance. First, anytime you run a cluster like this, you're going to want to use tensor parallel, and that essentially takes a portion of the model and you'll run it on one, you'll run it on the other, and then you'll end up doing a all reduce function and you go over the network. And so that's how this whole thing works. And that means that practically speaking, whenever you do a GB10 cluster, you don't really want like 5 nodes or like 3 nodes. So you're probably going to want to have either 1 node, 2 nodes, 4 nodes, or 8 nodes. Another big one, and is super important here, is that you might think, hey, If I have a small model and I'm running it across 8 different nodes, that means that I get 273 gigabytes per second, which is my memory bandwidth, but I get that times 8, and I get more little GPUs and stuff like that. So doesn't that make it like way faster? I should run, instead of just run on 1 node, I should run on 8. What we were often finding is that if we ran that same small model across 8 nodes instead of 1 node, we would get actually 6.5, 7 times better performance by just running a bunch of individual models on each of the nodes and then just going out that way. And that makes sense just because the latencies are so much higher going off package and over the network versus just staying on the package. So of course you would always want to go and stay on a single node or 2 nodes or whatever the smallest number of nodes that you can to fit the model. Especially with today's sparse mixture of expert models, you definitely want to go and use as few nodes as possible. And to make that really concrete, if you can run the same quantization on 1 node, it'll most likely run faster than if you're going to try running it on 2 nodes in TP2 mode. Likewise, if it fits in 2 nodes in TP2, it's going to be faster than 4 nodes TP4. And of course, so on and so forth on that. Also, despite the fact that the Blackwell GPU, the physical hardware, supports NVFP4, what the community has found is that a lot of times other quants do really, really well on the GB10. The hardware support is there, software support is still a work in progress, but there's a great community behind this. And so what we ended up doing more often than not was that we tended to run a bunch of 120B models on some of the nodes. We may run Qwen 397B, and we'll run that at, I don't know, man, set 15 to 20 tokens per second. It's not faster than the Apple Mac Studio M3 Ultra 512 gig, but when you start getting high, a lot of context, that's when you start to notice the difference. And the NVIDIA solution is actually better, or at least has been much faster for us. And because we're only using 4 nodes for Qwen 3.5, we might have 120 B models running on other ones. We might be doing just testing to see if new optimizations make things go faster or better, or a new model comes out, we might want to test that. And so we tend to use our cluster nodes a lot more fungibly than I was expecting. And maybe that's one of the best things about this, right? This space is moving so fast that having a flexible cluster like this, where you can still, you can use 4 nodes if you need to, or 8 nodes, or 2 nodes, 1 node, and just kind of mix and match as you need. That's actually a really good capability, just because stuff is coming out every week that is just mind-blowing. Really quickly, if you want to see some benchmarks, the GB10 community has really focused on this thing, sparkarena.com. So definitely go check that out. There's also a number of community resources. So there's Llama Benchy, which is always good. And then also there's a whole VLM Docker setup that one of the very active GB10 members has set up. So kudos to them for actually going and putting all this together, because I think that's absolutely great. And we're going to be submitting more to those soon. All right, now in all of these videos, I like to have key lessons learned. I mean, what the heck did we learn from this one? I think we have a lot, guys. If I were to look back a couple months ago, we were using, I don't know, a couple 100,000 tokens a day. We were generating a couple 100,000 tokens a day. By earlier this year, when the models got a lot better, we were using maybe 1 to 5 million tokens a day. Now it's not uncommon to see a 10 million token day. But it's kind of crazy, because as the models have gotten bigger, they require more compute, but because the output is more useful, we tend to consume more compute. I think that's the cycle that a lot of folks have been talking about. We've been talking about it on the STH main site and our Substack for a long time now. And I know there are a ton of keyboard warriors that are in the comments right now, not only that are oblivious to the fact that AI has gotten really good, but also folks are saying I don't need a $100 a month Claude code to set this up. I could do it all myself and all that. Yeah, totally. You can go do it yourself. You do not need to go use an automated tool and an AI agent to go do it. But let me give you why this was impactful. I had meetings all afternoon, and then I had to go take care of my son. And then in the morning, I was going on a trip for a week. And so I just had no time to go and set these up. And this is a lot of money of hardware just sitting around to not be used. And so I literally had a choice of either A, it doesn't get done, or B, I hand it to an AI agent and I let the thing go do it. That was a bit of an experiment. I'll give you that. But for a $100 a month Cloud Code subscription, be able to do all this and have it working the next morning when I woke up before I went on my trip, so I could go and play with it while I was on the trip. I mean, guys, that is a total game changer. And I also just want to address the elephant in the room, which is the Apple Mac Studio M3 Ultra 512 gig, which I absolutely love that system. The higher memory bandwidth is great. The fact that there's more memory in one system, I think, is also really good. The nice thing is that the RDMA networking over Thunderbolt is relatively inexpensive. It may not be as fast, but at least it's cheap and kind of easy to set up because you don't have a switch or anything like that. But on the other hand, because you don't have a network switch, you're not going to get your high-speed storage coming over that network anyway, right? But on the other hand, being able to stay in the NVIDIA ecosystem, get all those benefits as well. I think, frankly, the GB10 has a lot going for it, especially as you start to scale up these nodes or scale out the number of nodes you have. This, when we set it up, was like a $23,000 setup. Getting 2 Mac Studios would have been, about $10,000 pop when you could get them. So it would have been about $20,000. So either way, to get about 1 terabyte of memory, you're talking about $20-something thousand to get that all set up. So guys, just taking a bit of perspective here, I think that if we're talking about these in terms of the cost of a PC, is $20,000-$30,000, is that a lot? I think, heck yes, it is. But I think the reason for that is that these aren't being priced like they're a PC that's meant to play games on or something that, just running a spreadsheet. Instead, these are performing tasks like setting up this entire cluster and all the cool parts to that are more like what you would have a contractor come in and do or something. So there's no barrier to entry anymore other than, being able to go and spend maybe $100 one time to just go set this whole thing up. So that's awesome, right? Now guys, of course, I love to hear what you guys think about this. This was a super cool cluster. And the cool thing is that it is actually getting better. And as we get new models, it'll probably become more useful. So just to me, it's a cool thing to have now and it keeps getting better. So it's one of these weird things where if I were to buy a gaming PC, well, maybe back in the day, right? That would kind of get a little bit less useful over time, but this has actually become more useful over time, which to me is it's just an awesome thing, especially since we spent so much money setting this up. Again, I also want to say thank you to Micro Center for sponsoring this video. And if you did like this video, well, hey, why don't you share it with your friends and colleagues so you can know that this is possible. But also give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching. Have an awesome day.